So, hello, welcome to the episode of Flying High with Flutter. I'm your host, Alan Wyma, and today we have another special guest. So, we just had Bedrock in action. Now we have LLMs in action. Please welcome Immanuel Trummer.
Hello, everyone. Very nice to be here. Thanks for the invitation.
Yeah, it's good to have you on, right? We're here to talk about your book, LLMs in action. Like I said, we just had Amazon Bedrock in action. I think just on Monday of this week. And yeah, so I thought, also be great to have you on because I believe Bedrock builds upon kind of different LLMs, right? So we did go a little bit into, what is an LLM and things like that, but I think, it would be good to hear from somebody else, what is an LLM because you might get a different answer and it may help people to understand some more and provide more context. But before we even get into
Mhm.
there, it probably would be good that, I'm not the one who keeps talking and we kind of let you introduce, who you are and a little bit about your background if you don't mind, Emmanuel.
Yeah, sure. Happy to. Yes. So my name is Immanuel. I'm here associate professor of computer science at Cornell University in Isaac. And so my research is about large scale data analysis in general, often at the intersection with machine learning. And over the past couple of years, more specifically, large language models, which are those huge neural networks for processing text and many other types of data. And so I got started with working on large language models relatively early on the language model scale, which means before ChatGPT and everyone started working on it. And so I've been working on the topic for a couple of years. At the beginning, it was this a little bit exotic topic in my research community, and I got really excited about it. So I wanted to share that. And so I prepared a couple of tutorials on the topic at our conferences, also posted some of that online. And I think this is how many came across those things, and they reached out to me and asked, "Hey, this sounds cool. Don't you want to write a book about it with us?" And yes, that sounded great. So I essentially started working on a book around 2 years ago, I believe. And now it is finished. And yes, that's what I'm here to talk about. The book is called The Large Language Models in Action, Analyzing Text Tables, Images, and Sound by Manning. So yes, very happy to be here.
It's always good when the publisher reaches out to you, right? Because they definitely can see that you're, outputting things. I don't even know kind of like where we can start with this, right? Because yeah, well, where should we even start? I mean, if you would kind of explain what an LLM is, because I feel like LLM has now become a term where it's just an acronym that has a meaning by itself. If you break it down, people may not actually know what LLM actually means. So how would you kind
Okay.
of explain what that is to somebody?
Okay, that's a fair question. So yeah, LLM, that is generally abbreviates large language model. And I mean, at the core, that's a very, very large neural network for processing language, and nowadays also a couple of other data modalities such as images or even sound. And in principle, language models have been around for a while, but I guess they really took off when two key ideas came together. And one of those key ideas proposed in 2017 originally, that is the transformer. And we chatted a little bit before the show, and you also mentioned transformer. So that is definitely an important term in this context because the transformer, that's a novel neural network architecture that, among other things, it makes it easier to scale up training of those models to extremely large models with nowadays hundreds of billions or even trillions of trainable parameters. So that gives you some idea about how complex the model is going to be. And the problem now is you have this huge neural network with many parameters. You need to figure out how to find enough data to train that model with. And here the second idea comes into play, which is transfer learning. So before those large language models that we see nowadays, it used to be a little bit more like you have to train your machine learning model for one specific task on one specific type of data. In order to do that, you essentially need quite a few training samples, often thousands, 10,000s, maybe hundreds of thousands of training samples that essentially teach the model how to solve one specific task. Let's, for instance, say concretely, you want to classify comments by users on an online forum into positive comments and negative comments. For instance, if this is a forum that relates to some kind of product, positive comments means somebody is recommending the product, and negative comments means somebody does not like the product. And doing all of this manually, that takes too much time. So you want to train a machine learning model that basically takes one of those comments as input and then outputs either positive or negative. That's a binary classification problem. And now, a while back, you had to essentially find many, many sample comments and essentially manually assign them to one of those two categories. And you use that data in order to train the model. But it is quite tedious, and you have to do it for each single task that you're interested in, right? So nowadays, actually, you have models that are not really trained for one specific task, but in principle, they're able to solve a variety of tasks on nowadays a variety of data types. So you have those huge transformer models with hundreds of billions of parameters, and now you want to find enough data to train them. So you probably won't have enough training data for all the different tasks that you're interested in. So instead, you do something else. You take some fairly generic task, for instance, such as, hey, if I have like the start of a sentence, try to guess what is the next word in that sentence, essentially, right? It's a little bit like auto completion in a way. Now, this task itself might not actually be that interesting for us, right? Maybe you want to do many other things with your model, but you train it on solving this task really well. Now, the reason you might want to select this task is that you can easily find a lot of training data. If your goal is to just predict the next word in arbitrary text, then that means you can essentially just download text from the web or somewhere else, and you can essentially just cut off the last word in a sentence and then use that as training data for the model and essentially reward the model if it predicts the correct word, or if it does not predict the correct word, then you change the parameters of the model a little bit in order to make it more likely that it predicts the correct word. Now, why that task itself is not actually that interesting, it turns out that in order to get good at this specific task, just predicting the next word in a sentence, you have to acquire some kind of natural language understanding abilities, and you have to maybe even acquire some degree of common sense knowledge. If the sentence is, for instance, the capital of France is, then you have better chances of correctly completing that sentence if you have some kind of quotes common sense knowledge saying that this should be Paris, for instance, right? So in order to get good at this fairly generic task, where you can easily find lots of training data, you have to acquire lots of skills that come in extremely handy, also in order to solve all other kinds of tasks. Because, for instance, in order to map those comments to categories, positive or negative, you also need some kind of natural language understanding and common sense knowledge. And the nice thing is that it actually turns out if you have a sufficiently large model like GPT, GPT-3, GPT-4 size, right? You have a very large model, and then you use a tremendously large amount of data in order to train it on those generic tasks, like essentially use maybe some non-trivial subset of the entire text that you find on the web in order to train that model. Then why you have only trained the model on a fairly generic task, you can actually quite conveniently transfer the knowledge that you gained in order to get good at this generic task in order to solve other much more specialized tasks where it will actually be hard for you to generate enough training data to train a specialized model directly for that task. So those are basically the two key ideas that enable language models at the level that we see nowadays, the transformer neural network architecture, which is the model architecture, and then the idea of transfer learning, which essentially gives you a way to find enough generic training data for those very, very large models. And then the knowledge that you gain in the training transfers to many other tasks where training data is much more sparse. So that is what a language model is. And nowadays, besides language, of course, you also have lots of other data modalities that they can process, images, sound. All of that is also covered in the book.
So all this information is in the book. It sounds like there's quite a lot, and I was just kind of breezing through it today. And is it going to be released soon, or when's the release coming out?
Very soon. So it's currently in production, which means that
Okay.
they are now doing typesetting and everything. It should be released in the next couple of days. I don't have the
Oh,
precise date yet, but I mean, so
okay.
basically now all the production stage happens. Basically, the final version is in, and now it's just being polished and prepared for a print.
Okay, because there doesn't seem to be a lot of chapters. When I looked at the table of contents, it's quite small. That's why I was like, okay, it seems like it's still in the early phase. Unless, of course, each
No,
chapter
no,
is quite
no.
big. I
It
didn't look through
is.
every chapter yet.
Correct, yeah. So yeah, no, I think it's like for a technical book, it has the normal size, something like around 250 pages, something like that.
Okay.
So yeah, I mean, I also try to be like selective about what I'm putting in. It's an amazing topic. There's lots of things that could be written about it, but I try to really prune it down to the things that are directly useful in order to make good use of those language models in practice.
Yeah. Okay. I mean, I do have another kind of question though. I often see this GPT. Now, GPT actually has a very, it's like general something transformer, is it not?
Generative pre-trained transformers. Yeah.
Okay.
So generative because it is generating an output. There are like different models that, for instance, they can only generate output of like very limited size. But so here you are generating output pre-trained because of this approach that I outlined before. This is not a model that is trained for one specific task, but rather it is pre-trained in order to gain a lot of generic knowledge that will be useful for many different tasks, and transformer that relates to the neural network architecture.
Now, one thing I did find a little bit tricky is I was trying to generate some ideas with ChatGPT and it wasn't quite working out. And I was told by somebody that, oh, it's because you don't know how to ask the right questions to ChatGPT. I mean, is there really such a thing that you have to kind of state things in a specific way so that way you can understand what you want better?
Well, I mean, you definitely have to give it all the information that is relevant for the task. I'm not sure what specific type of task you have been looking at. I think it used to be a little bit more important the way you specifically formulate a task for the language models. For with current models, I feel that you have a little bit more flexibility. Even if you formulate the task in different ways, then you often get the same, like similarly a reasonable output. So yeah, I'm not sure. I mean, it can matter to some extent the way you express the task. I think the most important thing is that you provide all the important information that are required in order to solve the task. And what can help, for instance, is if you provide just a few, like one or two samples of correctly solved tasks of the same category in the prompt. What also matters is which specific model you use. If you use the ChatGPT web interface, for instance, in the background, that's actually quite a few different language models, and you can actually select between different models. It also depends a little bit on which subscription you have. So it might turn out that if it was a fairly complex task, then maybe you want to use one of the larger models in order to solve it well. So yes, it can matter to some extent, but nowadays it matters a little bit less than it used to. I think like the best thing that you can do is to include a couple of samples of correctly solved problem instances in your prompt. Of course, the next level, what you could do, which is also discussed in the book, is if you use a fine tuning. That essentially means that you create specialized version of your model that is really, really good at solving one specific task. It's different from training a new model from scratch for that specific task because you start already with, for instance, one of the GPT models, which are already pretty good typically at solving a variety of tasks. And then you just use a few hundred, maybe training samples for your specific task in order to make it even much better at solving the specific task you're interested in. What kind of task were you trying to solve actually?
You asked me what kind of test was I trying to solve?
Hmm.
Yeah, this is where I was trying to. So I'm doing a conference in Rust programming language, and we're
Hmm.
trying to design the advertisements for people, and I wanted to state something. I can't remember exactly what it was, but it was one of the bullet points of why you should come. And
Hmm.
it's tricky, right? Because you want to say something positive, of course. I mean, you want to sound good, but not cheesy, right? So it's I forgot what
Uh-huh.
I was trying to say, but it gave some interesting ideas, and I was like, this one I kind of like, but it's not quite there. And I wanted to,
Hmm.
what's the word? I mean, I guess you can say massage it more. I wanted to. It was a good starting point, but it
Okay.
needed to go somewhere, and I forgot what
There's a
exactly what
post
the
it, I
details.
think.
Yeah, so
All right. Hmm.
I
Hmm.
forgot. Like I just took the keyboard because the person who was typing, they don't know how to
Hmm.
actually use the typing style, with the hands on the home rules and everything. So
All
they're
right.
single key, they only can use two fingers at the same time, one on each hand, to type it in, and they keep looking at it, and it drives me crazy. And it takes a while for them to type. So I was like, let me
Okay.
do
So
it.
who was
Yeah, so I said, "Let me do it," and then I typed what I wanted, and then I pressed enter, and then they're like, "Oh, that's because you don't know how to do it. I saw a course online. I know how to do this." And
that?
I she
Hmm.
did it in another way, and I guess it was better. I didn't focus on that. I was too focused on the main idea, but I just remembered that particular experience, and I was like, "Okay, that's interesting." To me, that kind of
Hmm.
defeats the
Hmm.
purpose, right? Because you want these models to be able to handle
Hmm.
speech.
Hmm.
And the funny thing is, so it was actually me and two other people, and those two other people, their native language is not English. And I'm like, how come a native English speaker has a problem to use this language model in English, but they know how to use it better than me? It just seems like strange to me, at a high level.
I mean, one thing we should also say is that those language models nowadays they speak in quotes a variety of languages. But I think in this case, one thing that could help, for instance, in order to improve the chances that it produces exactly the style that you're interested in, is if you give it as input some advertisement text, maybe from different conferences that you liked. You can maybe specify one or two samples like that in order to like get the right trade-off between positive but not too cheesy on the other side. And I guess like that way it might be better able to copy the specific style that you're interested in. But yeah, I mean, I think like often, I mean, like it depends on what you're trying to do. I mean, like especially if I'm trying to use the language model in order to generate something a little bit more on the creative side, and it often it takes me a couple of iterations in order to get exactly what I want to. And I mean, it just sometimes I might not even know precisely what I want to at the beginning, and then I see something and I realize, hey, this is actually not what I want, and then I can like refine the prompt, meaning the input for the language model, in order to describe a little bit more precisely what I want. I, for instance, had that also like when I recently wanted to design a logo of a software project. I also used language models for that, and also the first twice I didn't like quite what I had, and I realized, okay, I need to add a little bit more constraints to my input, and that ultimately I got what I wanted. But it took a couple of iterations. So yeah, I think it's not unusual your experience.
Heavy iterations is fine, and I can understand that it's not going to give me the thing I exactly want or need at that time. I mean, there's almost no creative person who could, or almost no creative outlet that can 100% all the time give you exactly what you want, exactly all these things. It's really impossible. So I knew
Mhm,
that how to
mhm,
play with it, but I just didn't know, yeah, how I can state what it is I want, because like I just remember, you'd say, "Can you have some ideas for how to do something?" And then they would spit out about 5 to 10 things, and then one of the
mhm,
points was sounded good, and I was like, it's almost there, but it's missing something." And then they would say,
mhm,
"Okay, this one we like, but can you try it more like this?" And then it would
mhm,
spit out stuff, but
mhm,
yeah, it's
mhm,
tricky. But yeah, I mean, I didn't spend the time to actually look up any particular existing examples. I don't really feed in so much stuff like that. I think the only time I've ever fed in stuff is I would say, "Okay, this is my existing point, or this is the whatever, and I want
mhm,
to have it sound like this," and then it was able to help a
mhm,
lot with
mhm,
that. So that
mhm,
definitely,
mhm,
that's the one thing I've found the most use of AI, and I feel strange for saying that because people are doing interesting stuff with AI and LLMs. But like for me, I'm
mhm,
like,
mhm.
how do I make this thing sound better? Because I'm just bad in English. It's like my worst subject in school. So
Okay, all right.
so that's where I've gotten the most use out of it. And I think it does a really great job. I feel like people are very much like computers to a certain extent, where you feed it the right inputs and then you're going to get an interesting output that you may or may not like. Like if you say to your wife, "I love you," obviously you're
Mhm,
going to get something nice usually.
mhm,
As opposed to, if you give say something very bad to her, then you're going to hear something really bad back, right? So I feel kind of similar with this kind of stuff where it's like, okay, I want to have this emotion, I want to have this feeling, and then it's able to
mhm,
take existing words and put them into a way that helps
mhm,
convey the ideas, the feelings that you really want. And I find it kind of
mhm,
a little bit
mhm,
creepy to a certain extent that a machine is able to give these kind of things. But again, like I said, people I feel like are
mhm,
kind of like
mhm,
computers. You feed the right inputs, you're going to get the right outputs.
mhm. Well, I think definitely, I mean, the quality of the input influences the quality of the output. There are actually a couple of funny examples in that domain. For instance, there have been tries where people got better code out of language models by, for instance, providing them as a like with code snippet as a starting point that was better crafted or had like for instance had like higher quality comments, like things that are typically associated with higher quality code, and then the code that was generated by the language model would essentially also reflect that and be a higher quality code. So, I mean, I think in general, yes, I mean the quality of the input will in one way or another influence the quality of the output. One thing that I also should say here, I mean, like the examples that you were mentioning, I mean, like typing like an advertisement for a conference. I mean, this is a fairly short text typically. So that's in principle something that is still feasible to do by hand. Many of the use cases in my book, they actually relate to scenarios where you have to analyze a fairly large amount of data, where it is essentially not feasible anymore to do that by hand. And in those cases, you basically don't have a choice anymore besides using some kind of machine learning approach. Nowadays, you typically want to use a language models for that. So yes, I mean, it can sometimes be hard to get specifically what you're looking for from a language model, but definitely there are many scenarios where you just it will be unfeasible. It's not scalable to do things by hand anymore, and then you definitely want to use some kind of language model or machine learning approach in general.
Okay, yeah, interesting. I mean, the other thing that's also quite interesting too is that you can start to feed different kinds of data. I saw this in, I mean, obviously the subtitle of your book is that we've been talking about text, right? Which, okay, fine. It's
Mm-hmm.
not unusual for people to be able to analyze text. We've been analyzing text for a long time, but to start to bring in other kinds of mediums like audio and video and these kind of things. I mean, what kinds of interesting things are people actually doing by using these types of mediums? And then a follow-up question to that one would be, can you actually take the different forms of communication like video, audio, and text and get some kind of meaning from all of that together using LLMs?
Mm-hmm. Absolutely, you can do that. I mean, there are also some examples in the book of scenarios where you provide as input a mix, for instance, of text and images. And models like GPT-4o, O for Omni, one of the more recent models from OpenAI, they can absolutely handle that. So you can provide as input a mix of pieces of data with different modalities. So yeah, that is absolutely possible nowadays. And there's a variety of things that you can do with that. For instance, you can ask the model to identify objects in specific pictures. You can ask the model to compare different pictures or other data modalities. You can provide, for instance, videos and text as well as input. So essentially, and there's some examples of that in the book. So yes, I think nowadays you can analyze a variety of data types and actually often even like using the same model. That's one of the things that I find so exciting about this domain, that actually like areas like image processing, sound processing, and text processing, where you used to have models that actually use different architectures, and of course they're trained separately. Now you have essentially models that can handle all of those things together. So those are very universally applicable tools. And I mean, the other thing is, you said that text processing, we have been doing this for a while. That is true. But what is really exciting about this, and which is only possible since a couple of years, is that you can now do very generic, arbitrary text processing essentially with the same model without having to retrain that model for any of those specific tasks. I mean, so basically you just come and tell the model what kind of task it should solve with the text, whether it should classify the text or whether it should extract information, specific information from the text. And you don't have to actually train the model specifically for any of those tasks, but you can just describe what you want to happen in natural language and then provide the model with the input data as a source. So yes, so all of those things that you mentioned, like providing various types of data together as input, that is absolutely possible.
How are you feeling about kind of the current landscape? I mean, we're already doing getting quite far with things, right? What do you see like the future of LLMs based on everything that you've picked up so far?
So I think that there's going to be significant impact in variety of domains. I mean, the fact that those language models are those very universal tools nowadays, I mean, it does mean that you can apply them in a variety of different areas. I think people are coming up with new, exciting use cases every day, basically, whether that is in data analysis, robotics, even teaching. Nowadays, there's quite a couple of use cases. So I think it's a really exciting area. I mean, things are moving very fast, and there's like new applications basically coming up every week. So yes, I mean, it's hard to predict like which of those use cases will be the most beneficial in the end. But yeah, I think like due to the fact that they are so widely applicable, it will have impact in a variety of different domains.
We do this show live, and actually we do have a live comment. I'm just going to read it out to you. It is a question. So they ask,
Mhm.
I tried to ask ChatGPT or Claude to write a creative story for a few times. They gave a different story every time. I'm wondering what
Mhm.
kind of back end thinking they are using. How can they decide which creative idea to use? If it's a random process or AI have a mood in different instances. Sometimes they ask, the LLM, either Claude or ChatGPT for some creative graphics, and every graphic is a bit different, even with the same exact prompt.
Okay, that's an interesting question. And the answer is that indeed there is some randomization going on in the background. I mean, essentially, what the language model is doing in the background is that, for instance, let's maybe talk about text in order to keep it simple, but similar principles apply for all the other data modalities. So, for text, for instance, the language model gets that prompt as input, and then it essentially it passes it through this whole huge transformer neural network, and what it calculates in the end are essentially scores for different tokens. So tokens is essentially the atomic unit at which language models represent a text internally that can correspond to a word or only to part of a word. And those scores, they typically correspond to the probability a little bit that a specific token is selected as next word. So what you could do, of course, is that you just select as next token the token that has the highest score assigned. If you keep doing that, then you might always get the same output, assuming that there are no draws to be broken. But it can actually be very useful if the language model is generating at least slightly different replies each time that you confront it with the same prompt. For instance, typically those interfaces, they have some kind of regenerate button, which means that for the same output, you just want to see a different reply from the language model. So having some randomization in there is actually good, and it gives you a more diverse set of replies to choose from. So if you are using language models from APIs such as the Python API by OpenAI, which features quite heavily in the book, then you can actually choose the degree of randomization. There are different parameters that you can use in order to do that. For instance, one of them is called the temperature, and the temperature essentially chooses the degree of randomization that you want to use when mapping from those per token scores to the token that you select next. So with no randomization, you would tend to choose the token next that has the highest score. Basically, with lots of randomization, then you would essentially, in the extreme case, disregard those scores and just randomly select the next token, which is typically not what you want. So typically, you want to choose some sweet spot somewhere in between where you allow for some degree of randomization, such that you can, for instance, get sufficiently different answers from the language model when generating answers with the same prompt multiple times. But you also want to have the randomization sufficiently low that the output somewhat relates to the input and is somewhat reasonable. So, yes, short answer to your question, there is no mood swings of the language model, but there is indeed some randomization at play in the background. And depending on the interface over which you use the language model, you can actually tune the degree of randomization that you're getting. Great question, actually.
Now I think I've seen something like this before in terms of like where I asked a question a couple of times different. Obviously, there was some time in between, and I didn't come to my mind right away, but it gave me different answers, and I was like, "That's really weird." I don't remember what the question was, but now I have some concerns. Right? I mean, obviously, there is that kind of somewhat famous case where a lawyer used this to generate like a I don't remember what it was, some kind of legal document, and another lawyer signed off on it, and without actually reading it, right? I mean, that kind of
Mhm.
stuff's a little bit scary that ChatGPT or I don't remember. I'm not going to say it was ChatGPT, but I think it might have been. But these large language models that can just kind of make up things, right? I think I've actually seen it where
Mhm.
it made up an answer, and I thought that was really weird because no way this is true
Mhm.
because I know more than this. How is it that these things are supposed to be helpful, but at the same time they can make up something that is not even
Mhm.
close, or even if you start asking questions about, oh, what is this, and then it says, oh, that's not even exist. How does this kind of
Mhm.
stuff
Mhm.
actually happen, and it's okay?
Okay, that's a good question. And I mean, there's even like a dedicated term for that, that is a hallucination, if the language model is essentially just making up stuff. And actually, I still remember, like you mentioned, like that example of the lawyer. Also, a couple of years back, it actually used to be quite common that the language model would make up citations, like from like it would make a point about something, and then it would essentially provide a citation of a scientific paper that supposedly supports that point. The only problem is that those papers often never existed actually, and I have some funny stories from colleagues who actually got asked from people about, hey, can you please share a draft of that paper? ChatGPT told me that you are writing this paper and it relates to the topic that I'm interested in. But the problem was that those papers never actually existed. And I mean, that would be one instance of hallucination. So that can, in principle, happen. It actually has gotten a lot better in my experience. A couple of years back, I was actually able to quite easily get it to make up essentially scientific papers that didn't exist in its answers. And nowadays, that's actually very hard to do. So I think that people have been spending time working on improving those hallucination effects, and I think they have had some success already. But on the other side, of course, I mean, if you have the answer of a language model, then you don't want to trust it blindly, but you want to verify that what it gives you is actually accurate. One way in which that has become much, much better actually nowadays it is that those language models, they used to be somewhat isolated, meaning that they generate answers only based on the knowledge that they have internalized in the model itself. But nowadays, those models actually have access to the web essentially. So the language model will actually be able to essentially search the web in order to find relevant information for the topic that you're interested in, and then can also provide the links to the source material that it has used in order to generate the answer. So that is nowadays done by multiple providers. You might actually see it even in Google search, for instance. They have some AI generated answers sometimes. And along with the AI generated answer, you also find some links to the source material that has been used in order to generate that answer. So, I mean, general hallucination has gotten much better in my experience. It can still happen, but you typically have the possibility to verify answers generated by the language model to have a look at the source material. And I generally recommend to do that before you publish something, for instance. Of course, you definitely want to have a good look at the source material, but nowadays it has become much easier to actually verify that.
That's good that you can get this stuff now. That's the one thing that always seems to worry me is, okay, I asked the question, I got this answer. It seems like it's okay. But then if I have to
Mm.
go back and verify it, I mean, it depends on how much I want to verify, right? Because sometimes if you go back
Mhm.
and verify it, you basically got the answer, like whether
Mhm.
it was correct or not. I mean, if it was correct, it's like, okay, great. But does this mean that
Mhm.
next time I can trust if I ask something in a similar range? At what point should you start to trust and how much should you actually check? I guess it depends on what you're going to do with it, right? If you're writing case law, then you really need to check
Mhm.
it. If you're asking something that's not needing me to be exact, then it's okay not to verify so much.
I mean, I think you have to be very conscious about like the use cases that you apply those language models for. So I think it depends a lot on the context, how much verification you should do. I'm not sure whether you should use it too much for writing a law text in general. But I mean, if you do, then you probably want to check at least a little bit. You mentioned that example for where that went wrong. So, I mean, it depends entirely on the use case. I mean, I think you should be aware of the fact that you cannot blindly rely on the answers generated by a language model. So, depending on what you want to use the answer that you obtain for, you it's probably a good idea spending some time verifying the answer. It might also sometimes, I guess, like if you have an answer and some of those parts seem a little bit more unusual or a little bit more doubtful than others, then you typically, I mean, you have like actually, for instance, like with the Google answers, you have like links to specific parts of the generated answer. You wouldn't have to verify everything, but you can maybe verify the parts that seem particularly doubtful. Yeah, so I mean, I think in general, the high level message is, yeah, you don't want to trust blindly the language models, and then depending on what you want to use the answers for, a different degree of verification is justified. And I mean, right now we are talking about like generating text answers primarily, I guess, but I mean, the same principle applies when using language models to generate code, for instance. I had a couple of projects where I used language models in order to generate code and then execute it, but I would not do that on my own machine. At least I would not like blindly execute code generated by the language model without checking on it. So I used some external machines for that, which turns out to be a good idea. I actually I had a case where something worked actually very well in like 99% of cases. The generated code by the language model was correct, but there was this one case where the language model actually generated code, filled my entire multiple 100 gigabyte disk on my virtual machine with junk data, basically. So I'm happy that this didn't happen on my computer. And in that context, I think the appropriate way was to make sure that the language model executes the generated code not on my own infrastructure, but on something that it can fairly easily terminate and just erase, basically. So yes, I think depending on what you're using the output of the language model for, you will have to implement some kind of verification or security mechanisms in order to make sure that there are no bad effects. The high level picture, yes, language models, you cannot trust them. They work well in many, many cases, but you don't want to get into a scenario where you blindly use the output of a language model in some critical use case. So that is just something to keep in mind. I think also like when taking something generated by another a person, you also would want to apply a certain degree of care and make sure that all of this is accurate. But yes, I mean, high level picture, don't blindly trust the output of language models.
Now, I have another question. We're asking all these questions to these different large language models.
Mhm.
Is it actually building up a profile about us? I mean, because we have an account, right? Let's say you're a medical student and you start asking questions about, you know, STDs and stuff like that. Now, maybe
Mhm.
it might say, "Oh, this user apparently, is sexually active," and but just so happens that I'm just saying, like, you may just be doing something and it starts to kind of build up this profile about you. Should we be kind of worried about this kind of stuff that we're using these models and it could be starting to figure out who we are and what we're doing?
It's a good question. I mean, privacy, I think, is generally an issue with language models. I think providers are also aware of that fact, and there are like different ways in which you can opt out of like data that you provide as input to the language model being used for training purposes, right? So, I mean, this is something that providers are generally aware of, and there are some mechanisms that they provide in order to give you some control over that. Typically, with this extremely sensitive data, then one thing that you can always generally do is that you essentially run your own models and then you control how the data that people input into those models is used and whether or not specifically it is used for training. I mean, one thing is definitely true. If you do provide information, personal information, as input to the training, like if that is part of the training data set, then in principle, yes, models are able to replicate some of that. So there's some mechanisms that try to to mitigate that. But I mean, in principle, yes, if it is part of the training data, then it might in principle get reproduced at some point. So I think that, I mean, I mean, you would want to verify very clearly what the current like guidelines are, like what the rules are in terms of like what gets used for training data by specific providers. You should find some information about that online from your provider, and inputting very sensitive medical data, I think, might be problematic. What you could do in those cases is that you essentially, if you want to be on the completely safe side, of course, what you can do is that you run your own model on your own infrastructure, maybe even. And in that way, you're absolutely sure that none of that data gets shared in any way. But even if you use the models of larger providers, then you might have some kind of guarantees from the provider about how the data that you input into the model is used. But yes, that is absolutely something to be aware of. Don't input sensitive data into models where you have no clear idea about whether or not the data might later get used for training purposes.
Okay. I don't think I have any more questions because, we've been covering these topics the last couple of days and you kind of answered a lot of my questions, let alone I feel like your book is going to have a lot of details in here that for the questions I would ask. So I prefer to go straight to the source. But it's also good to hear that your book is basically ready to go. It's just kind of, in the final
Mhm.
stages of production.
Almost finished the preview version directly from Manning. Once the production finishes, then we get the full version.
Yeah, so you can get the like the live book version or whatever it's called, right? I think it's called live book.
Correct. Correct. Mhm.
Yeah, so that one, yeah, in any case, so again, the name of the book is called LLMs in Action, right? So if you ever see blank in action,
Mhm.
that's always the Manning title. So LLMs in Action. It sounds quite interesting, so I'll have to get into it. And we'll probably have a code once this episode comes out, so it should be in a couple of weeks. So if you guys are listening, just stay tuned, and we'll announce that with Manning. And is there anything that we didn't get the chance to cover that you wanted to say?
Honestly, I think we covered pretty much everything. So, yes, thanks for the invitation. Thanks for the interesting online questions.
And thank you, right, for answering my questions. I feel like some of my questions are maybe a little bit on the beginner side, but I am a beginner, and I'm very happy to admit that.
That is totally fine. And I should also mention, I mean, this book, I mean, it is really like targeted at beginners in that domain. So you don't need any prior knowledge about language models. Everything that is relevant will be explained in the book. You might want to have a little bit of Python background because the code samples are in Python. But yes, so the book is actually targeted indeed at beginners, and you don't need any prior knowledge. And yes, those questions are absolutely relevant and interesting, and also to some degree, some of those questions are covered in the book too.
Great. So you're saying I don't need to purchase the book now. I got all the answers I need.
Oh no, 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 no.
Yeah, I figure you go into a lot more depth. And then I was browsing through the book because I have a review copy, and I saw that actually at a high level there's like only like 10 chapters, I think. And so it didn't look
Mhm.
like there was a lot, but then I forgot you have to actually, open the tree, and then I saw, oh, there's another 50 points for each chapter. So actually it is quite much
Yes,
more in depth than I thought.
subchapters. Yeah, absolutely. Yeah. No, I think it's a good portion. I mean, it will give you the background that you need in order to really develop code that uses language models. So yes, we covered like some of the high level basics, but yeah, most of the book is actually quite hands on about how to develop applications that use language models to analyze text, object recognition in images, building voice query interfaces, or basically, yeah, like how to analyze almost like any kind of data with almost any kind of task, but how to use those language models as a very universal tool for data analysis.
Perfect. Well, again, it was great to have you on, Emmanuel. Just one last time. It's called LLMs in Action, and we'll probably have, like I said, a special code, and we'll announce that. So, again, thanks for coming on, and hopefully, we'll have you back on again in the future.
Sounds great. Thank you.